Hello, hello. It is week 9, and we can see we're nearing the end of our CAD portion of ME250. And as always, we can go to the CAD calendar and check what we're going to be going over this week, sections 13 and 14, in context modeling and using design tables. We're really going to focus on the design tables portion, and then we're going to show another method of doing the same thing that the Lynda videos don't cover, which is using variables inside of SolidWorks. So to start, as always, I'm going to create this part along with you, and we can immediately see some things are different. We have variables here rather than dimensions, and we can see we have got this little table here telling us the equivalent dimension for those variables. So there's two ways we're going to go over it today, so it's going to be a little bit of a longer video. The first method I'm going to do is design tables. Big caveat with that is you have to have Excel. SolidWorks has a nice integration with Excel, but only with Excel. So you can't do a CSV file or anything else. And so the other way I'm going to show you doesn't need Excel. It's built right into SolidWorks. That just means we're going to have a long video today. So I'm going to start by making this with the design table. And so I'm not going to worry about these dimensions. I'm just going to get this general shape, and I'm going to name all these variables what I see in the sketch as I go along and create it. So I'm going to start with making this parallelogram here on this top plane. So parallelogram's right up here. I don't think we've ever used it before, so just in case you forgot, it's right up there. I have add construction lines on. I like having those there. SolidWorks has them off on default. So I'm just going to go ahead and sketch this general parallelogram. Going to make it coincident. Going to make this horizontal, which I believe it already is. Yes. And then I'm going to create these dimensions with these variable names, and I'll go ahead and show you how. So we can see this one is A, that's B, and that's C. So when I go and do this, I'm just going to go ahead and make that A right up there. And I'll show you again for B. We're not going to care about the dimension right now, but I'm going to go ahead and change this name. That's B, and this one is going to be C. And as always, we want to be fully defined, which we are. So I'm going to go ahead and extrude this out. And we don't care about the dimensions right now, but I'm going to go ahead and extrude it. And then I'm going to change the name of this feature. We can see here I want to call P extrude. That's just for parallelogram extrude. So I'm just going to click it, and then it's going to go to changing its name, P extrude. And then we'll see these names all pop up again here when we get to the design table. Next thing I'm going to do is go ahead and create the circle on the back face of this parallelogram. Actually, let me reorientate myself. That's the front. I'm going to sketch on the back here. Going to go normal to it. Create this circle with the same center point. Make these coincident at the edges here, and then that'll make it fully defined. And then extrude. Again, don't care about this dimension, but I'm going to change this to CI for circle. Extrude. And last thing I'm going to do is go ahead and create the slot here on this face of the parallelogram. So I'm going to go normal to it, start this sketch, create this center point slot right on the origin. And again, not going to care about the dimensions just yet, but I'm going to keep that, change the name, slot L for slot length, and then slot R for slot radius. Slot R. And you'll see this at sketch 3 pop up. That doesn't really matter. That's just showing you where in the feature tree it's going to be. So slot R is all we really care about, is getting the before at sketch. So everything's fully defined. Again, going to go ahead and extrude cut this. And again, we don't care about how much just yet, but I'm going to rename this to cut extrude. So now we've got all our variables named just like they are in our drawing here, and I'm going to start making this dimensionally accurate to match these dimensions given here, and I'm going to do that the first way with a design table. And big caveat with that is Excel. You have to have it. Like I said, it has to be installed. There's no other option. It's nicely integrated, but you have the risk of using Excel, and you have to have Excel. All of our lab computers do have Microsoft Excel, and they do run just fine, but keep in mind, Excel crashes, SolidWorks crashes, you're putting them both together, likely to crash. So if you're doing this, save often. I'm going to change the material before I go into the design table because it's going to create different variations of this part, and I want to change the material now rather than later. And it's ABS plastic. It's going to be the first option here, and go ahead and apply it and make this part nice and white. We can see the material right here. So now I'm going to go ahead and create or insert this design table. So I'm going to go right back to my part. I'm just going to go normal to it, and we'll go to Insert Tables, Design Table, and then we want to auto create. It'll do a good job doing that for us. Excel's going to pop up here. It's going to ask us what features or what entities we want to include. I want to do all of them. And then we'll see all of our dimensions pop up right here. And we got ABC. We got this exact design table we see in the drawing. The only difference is this is ABC and my drawing is BAC. That's just a little oversight. But I'm going to go ahead and copy these dimensions into our design table in SolidWorks. So 80, 50, 70, 80, 50, 70. Both of these are 10. That just so happens to be correct. And then this slot length is going to be 55 with the radius 3. 55, radius 3. And our cut is going to be 15. So this is why we went ahead and named them. We can kind of see the variables and the entities that we're dimensioning right here in the sketch. So we can see right here, we're going to have our default variation of this part. So to start, I'm just going to go ahead and exit this, and you do so just by clicking anywhere outside. And it's going to go ahead and add all those dimensions. So if we go back to the sketch, we can see now that they're kind of pink. That's meaning that it's getting its dimension from a design table. So now I'm going to go ahead and just check this one's mass, 188.64, 188.64. So we should be good for this one, but now let's say we want to change all these values to be exactly a third smaller. So rather than go through by hand and change all of these, we can go back to our design table right over here, edit this table, and create some new variations of this part. We don't want to change the color description, so I'm just going to go ahead and press OK. So I'm going to make this new version of this part. I'm going to call it third smaller. And since this is straight up Excel, we can do exactly same formulas that we would do in Excel. So I'm going to do the third smaller. It's going to equal to that times 1/3. And that'll make this 1/3 smaller. Then I'm going to apply this to all of our dimensions, and it's going to create a variation of this part with that exact same, with these new dimensions. And then just create a different version of it. I've got this one called version 2. Oops. Version 2. And then I'm going to go ahead and copy these, which is 20, 10, 15. 20, 10, 15. The cut extrude, or the extrusions for the parallelogram and circle are both 5. So I'm going to go ahead and do that. 5 and 5. And then the slot length is 3, radius 0.5, and cut extrude is 3. So 3.53, 3.5, and 3. Cool. So when I exit this design table, it's going to go ahead and create these new parts. We'll see this. It says, congratulations. We made these two new configurations. That's the official term. Configurations of this part. I'm going to go ahead and click OK. And now we can see we have these different parts. If I go ahead and click them, it'll load in that different variation of the part. And I can go ahead and open up the third smaller version, which, remember, all the versions are, or all the dimensions are a third smaller than our default. And let's check our mass. It should be 6.99, 6.99, and then I'll go to this version 2, which just has some other random dimensions, and that should be 5.3, 5.3. Perfect. So that's one way to do this using the design table. Again, it's very powerful because you get the full power of Excel, but at the cost of having to have Excel and using Excel. And it does create different configurations of a part. So if you're trying to create something like the Lynda tutorials do, they do a great example of a 2x4. Obviously, a 2x4 is going to have the same 2 dimensions, and then it's going to change in its length. So if you want to have, like the Linda example, use the door frame, you have a couple standard lengths of 2x4. You can go ahead and create one part with different configurations, just being different lengths of 2x4. Now, the different version method I'm going to do is going to be based around creating variables in SolidWorks. This is going to be more for if your entire design is based around something that's changing. So say for this, we didn't care about having different configurations of this part, but we wanted this whole thing to be based on dimensions that are somewhat unknown or not known to us just yet, something like that. We can go ahead and make these dimensions in SolidWorks, and then when we get these dimensions, we can update this easily inside of a kind of a design table. So I'm going to go ahead and redo this part using variables in SolidWorks. So pretty much the same idea. I'm going to start this sketch. I'm going to go ahead and create that parallelogram. I'm going to make this horizontal. I'm going to shift this over a little bit. That's shifted the wrong way. Create this parallelogram just like before, and then we'll just get to our one little change that we're going to do. So rather than changing this sketch name to be A, I'm going to do, for the dimension variable itself, equal to A. And then this little thing's going to pop up saying we're going to create a global variable, and then that's going to get stored in the feature tree in a equations folder where we can easily go ahead and change all of those at a later time. So I'm going to go ahead and click OK. Oh, nope. I don't want it to be arcsign. I want it to be A. So I'm going to hit the check, and then we'll see this little summation sign right here. That just means it's a global variable. And again, we don't care about the dimension right now. We're just going to go ahead and dimension this thing through. So again, this is going to be B right here. So I'm going to do equal B. And one thing that's going to happen on your computer is when you click check mark, it's going to say, are you sure you want to create a global variable? I clicked yes, and then I said, don't show me this dialog anymore because we're going to be doing it a lot. So we can see that these are global variables. We're going to start to fly through this. So that's equal to C. Exit the sketch, extrude it. Perfect. I'm going to call this the same thing. Actually, edit feature, and then for this, we're going to make it equal to P extrude. Perfect. You can see right here, we can't really see the summation sign very easily, but if we go into this feature, we can see this icon right here. It means it is a global variable. So we're good here. I'm not going to rename the feature itself because I've already renamed the variable of the dimension in the feature. It's getting a little complicated, but bear with me. You'll see it's kind of simple. It's kind of like the thing before. So I'm going to go ahead now, go on the back plane, sketch, same thing as before. I'm just going to sketch this circle, make it coincident here. Perfect. It's fully defined. And feature extrude. I'm going to make this equal to CI extrude. Perfect. And then I'm going to make this slot, sketch there. Let's go to normal to it. Create this center point slot right here. Smart to mention this. Equal to slot L. Cool. And this is going to be equal to don't know what's going on here. Okay, we're good. Equal to slot R. And again, fully defined, extrude cut. And this is going to be equal to cut extrude. So again, point of doing this as a global variable is if you have a dimension that's going to be repeated over and over again. If, say, this variable A was used here, but also used for the length of the slot, you can use A here, and you can also make this A, and when you define the variable A, it'll obviously apply it to all the variables named A. So I've got this part. Again, I'm going to go ahead and change this material. I'm going to go ahead and make it plastics. First option, ABS. And then we see this new thing in the feature tree, equations. Hit the drop down, we'll see all of our options for equations. I'm going to go ahead and manage the equations. Then right here we see all of our variables and their values. So kind of the same thing as before. Go ahead and copy it. So for our default one, it's going to be 80, 50, 70. 80, 50. Yep, we're not, this is just saying it's going to cause some errors. I have this automatically rebuild on, so I'm just going to turn that off so that way we don't get it rebuilding until it's fully defined with variables we know work. 80, 50, 70. This is going to be 70, 70. These are both 10. Slot length is 55 and 3. So 55, 3, and 15. Perfect. Going to go ahead and press OK. It's going to go ahead, create that. You can rebuild it if you want. That's kind of like the refresh of SolidWorks. And then we should be able to go here, hit our sketch, and we can see it changed all of our dimensions to what we want. And go to evaluate mass properties 188.64. You can also apply some mathematics or formulas to this, obviously, in the equations area. So if I go manage equations, you do 88 times 1 divided by 3. And then you can see it equates or evaluates to that times 1 divided by 3. This is where the Excel version pops in a little bit faster if you have a machine that can run Excel quite fine without an issue. But show works, I'm just going to go through, do it manually. And you know what, I'm just going to copy that and paste it. There we go. And we can see its value is, its actual value is going to be shown here. Press OK, and it's going to resize this part. I just have a habit of rebuilding the document. I'm going to check the mass properties, 6.99, 6.99. Then if you do the same for version 2, it'll end up with the same mass. That's how the quiz is going to pretty much be. We're going to give you a dimension with variables, and you'll have to be able to quickly change all the variables either with a design table or using equations in SolidWorks. There's no right or wrong way. It's just whether or not you have Excel and trust the lab computers to run Excel. Yeah, you'll have to quickly change all the variables and show us you understand either variables or design tables. So that's it for what I believe is the longest video I've ever done. All right, thanks everyone.